We are Group 1 from Section 5. Me, Selena, Alok, Ziyu will be present our project. Now, I will start our presentation with problem description. As an electronic engineer, we are required to design a fire extinguishing system in the shopping mall. In our design, we have three inputs, which was S, Y, and Z. S it represents the presence of smoke, Y is represent of high temperature change, and Z is represent pressing a button. And these three inputs will generate four outputs, F, G, H, and I. Next, we look into block diagram. This diagram is present the input S, Y, Z will generate output F, G, H, and I. Next, truth table. Let's take rows 4 as our example. When S equal to 0, Y equals to 1, and Z equals to 1, all of our output will be equal to 1 as two input are fulfill the requirement. So next, I will pass to Carlo.
Next, we move to Carnot and minimal expression. By taking example of f, we can see it contains three loops. For instance, this green loop represents xz. As a result, the minimal expression of f will be xy or sz or yz. In addition, this is the logic circuit in Quartus Prime, and this is the logic circuit of f. It represents minimal expression of f, which is xy or sz or yz. This is another example of logic circuit. Its output is G, and its minimal expression is X or Y. Now we move to logic NAND gate design. This is the logic NAND gate of F. It will generate the same output that I have mentioned just now.
Alright, let's go back to the simple logic circuit. As mentioned, by the aid of the Quartus Prime, we may generate a simulation of waveform, which can classify as two types, which is the fractional simulation and the timing simulation. The fractional simulation of both design will produce the same result, which is as shown here. For example, taking the first row, the input of x, when the input of x, y, and z are 0, the output of f will also be 0, as same as the g and I. And the exception is the h. It will generate the output of 1. Taking another example, so when the input of x is 1, y and z is 0, we will generate the output of f, h, and I as a 0 and g as a 1. So let's go to the timing simulation. Timing simulation will produce a slightly different result of waveform than the fractional simulation, as it contains some of the delay time. For example, the output of f delay as 4.672 nanoseconds, as shown in the waveform. We may calculate the delay time by using the 34.672 nanosecond that label by using the line, and minus it with the 30 nanosecond of the grid. And hence, we may obtain a 4.672 nanosecond of delay time for the output of f in the simple logic circuit. And taking example of G, the delay time is 4.904 nanosecond, and the way of calculation is exactly the same as the f. So now we are going to the timing simulation for the NAND connection. As mentioned just now, the timing simulation of the NAND connection of the circuit is also have a slightly different with the fractional simulation, and it also has some difference than with the timing simulation of the simple logic gate. For example, taking the output f as the example, the delay time that shown by the NAND networking is 4.496 nanosecond. The calculation method is the same as just now, 34.496 nanosecond minus 30 nanosecond, and we will obtain a 4.9496 nanosecond of delay time for the output of F. And for the output of G, the delay time is 7.28 nanosecond. So by comparing the delay time of both design, we can say that NAND networking would be better to use in this system, as the delay time has been shortened, and it will represent that the response time has been faster. For example, the delay time for the NAND networking is only 4.496 nanosecond, and it is less with a value of 0.176 nanosecond than the circuit design of using simple circuit. With a shorter response time, the system can be function faster, and it may help to extinguish the fire in a shorter time, and it may reduce the loss and save more life.
Okay, in conclusion, we have successfully designed the fire extinguishing system. We follow the task by inserting three input to generate four output as expected on the early design of the system. This purpose of system is to reduce the damage of fire to individual and environment. Hence, reduce the loss of property and save more life. That's all. Thank you.